So you should be on a new clean page in your science section of your vocab notebook. And the title of this lesson is Chapter 8, Lesson 4, Stars and Constellations. Chapter 8, Lesson 4, Stars and Constellations. That's a 12. I just keep wanting to write 21 today. And we're going to start with number 1. However, we're not there yet. So once you're done, put your vocab notebook under your textbook and then open your textbook to page 392. Okay, so now we're going to do this look and wonder. Remember, look and wonder means you think about your answers, not out loud, like on the reading lesson when we do the talk about it. So we see that this picture was taken at Kitt Peak National Observatory in Arizona. High above the Sonoran Desert is the largest collection of telescopes in the world. What can they tell us about the night sky? So we see these telescopes. They don't look like a telescope you've probably ever seen in your life. They look like these weird buildings, like silos, like grain silos that we see on farms. But those are actually telescopes. They house the telescope. So the telescope is inside of there and it's massive. And it can open and close so that if it's raining or nasty, they can close it, or daytime. And then at night, when the sky is clear, they can open it back up. Okay, please turn the page. And Zadie, please read us the main idea.
Main idea. Stars are spheres of hot gas that give off light and heat. Stars can be grouped into constellations.
So, are stars like balls of fire? Are they planets? Are they a piece of rock that has light on it? No, it's just a sphere, which is, remember, a sphere is a 3D circle, so like a ball shape, of hot gases. So that means it's not like a ball where it's solid, it's hot gases. Like, remember when we talked about landing on Jupiter? What would happen to us? Would we like stand in one spot, Mason?
No.
What would happen to us if we landed on Jupiter? We'd fall straight through. It's the same thing with stars, except not only would we fall through those places, but we would burn up before we even had a chance to fall. Because they are made of hot gases that give off light and heat. Constellations are groups of stars. Who's heard of Orion's Belt? Or the Big Dipper? Or the Little Dipper? Those are constellations. They're groups of stars that kind of look like different shapes. Okay, Zadie, go ahead and read the first paragraph.
What are stars? For thousands of years, people have observed stars shining brightly in the night sky. A star is a sphere of hot gas that gives off light and heat.
So, what's our first vocab word, Zadie?
Star.
Star. And what is a star?
A star is a sphere of hot gas that gives off light and heat.
A sphere of hot gas that gives off light and heat. Yes, Victoria, quickly. Is this about a constellation? Okay.
It's just got a word in there.
Okay.
Gas isn't it
A sphere of hot gases that give off light and heat. So let's think, is it a planet? Do the planets give off light? How do we get light on planets? Where does that light come from? Lena?
The sun.
The sun shines on it. So the sun gives off light, right? Is the sun solid like a planet? So we could say the sun is a what? Carla?
It's a star.
A star. And if we said the sun is a star, we would be correct. The sun is actually a star. Now they look completely different. Why do you think the sun looks so different from the other stars in the sky? Victoria?
Biggest star?
Not the big. Nope, it's not the biggest. The sun is not the biggest star. Why else would it look so much bigger than all the other stars to us? Zari?
Maybe because the sun is shining on that one star.
No, the sun is a star. The sun is a star. So why does the sun, our sun, look so different to us than all the stars? Not because it's the biggest star, because it's not. Aaron? It's not brighter. Lena?
It comes out in daytime.
The sun is out all the time. Remember, just because we can't see it, is it gone? No, we're just on the other side of the earth.
Because the sun looks closer.
Not because it looks closer, but because it...
Because it is closer.
Because it's the closest. We are the closest to the sun. That is why it is the same as all the other stars, but it looks so much bigger and it looks so different. Because we are the closest and we also orbit around the sun. That's why it looks so different to us. Quickly, Mason, and then we got to move on.
What is the biggest star?
I don't know, but it's not the sun. Okay. Zadie, you know what? Keep going. You're loud, you're slow. Keep it up.
The only star you can see in the daytime is the sun. The sun might look different from other stars, but it's rather ordinary.
So, it's rather ordinary. What does that mean about the sun? Michaela?
It looks different.
No? Smith?
It's pretty much the same as the other stars.
It's pretty much the same as the other stars. There's really nothing special about it. It's special to us because without it, we would not be able to live. But compared to the other stars, it's not really that special. It's not the biggest. It's not the smallest. It's just a very average star. So do you see how something that is very average to other people means the world to someone else? It's just like the sun. The sun is just average when you're with all the other stars. But to us, it's the most important thing in our lives. Because without it, would we even have lives? No, we wouldn't. So think about that. Okay. Thank you, Zadie. Read next, Lena. Loud and slow.
Compared to other stars, the sun has an average size. Its surface temperature is average too.
That means it's not any bigger than the other stars. It's not any hotter than the other stars. It just is.
Why does the sun look bigger and brighter than any other star? The sun is the closest star to Earth. Other stars are much farther away.
So, very good to those of you that tried to figure out why the sun looks so different to us. And very good to Smith and whoever else figured it out without raising their hand. Because it's so much closer. That's the only reason. Keep going.
Colors and temperature. Have you ever noticed different colors of stars? The colors are due to temperatures. The sun's temperature makes it look yellow. Cooler stars are red or orange. Warmer stars are white or blue.
Okay, hold on one second. I'm sorry,
Lena,
Lena, go ahead.
Colors and temperature. Have you ever noticed different colors of stars? The colors are due to temperature. The sun's temperature makes it look yellow. Cooler stars are red or orange. Warmer stars are white or blue.
So sometimes if you look up at night and you look at the stars look like they're different colors. Some look a little more blue, some look a little more red, and then our sun just looks yellow. Well, that's because of how hot they are. So the sun's temperature is kind of in between. Remember, it's not really hotter than any other. Also, it's closer. So it looks more yellow. It's kind of in the middle. But cooler stars, stars that are cooler, look red or orange. But warmer stars are white or blue. So imagine a sink. Usually, the cold water has what color on the handle? Carla?
Blue.
Blue. And the hot water has what color?
Red.
Red. Stars are opposite. So, think of a sink, but then think the opposite for stars. Because we know in a sink, warm water is blue, the color, not the actual water. Hot water is red. But stars, hotter stars are blue, colder stars are red. So when you're trying to figure out which ones are hotter or colder, imagine a sink but backwards. So imagine if somebody installed a sink incorrectly. And so when you turn the red handle, cold water came out. And when you turn the blue handle, hot water came out. Okay? Super quickly, Zadie.
Because actually when things get really hot, they sometimes turn blue.
Well, a fire. Think of a fire. The middle of a fire is like white or sometimes even a little blue. If you look right in the middle, that's the hottest part. And then as you get further out, it looks more like reddish, orangish, yellow. That's because fire that's really, really, really hot is like a white or blue color. Mostly white, but you can sometimes see a little blue. The fire that's cooler, the outside, is more orangey, yellow, reddish. Okay, we have to move on. Otherwise, we won't finish. Okay. Lena, go ahead.
A star glows for a very long time. Our sun is about 5 billion years old. Scientists think it will grow for 5 billion more years.
Not grow, but
Think it will glow.
there you go. Because it's not going to get bigger. It's going to stay the same size. So that means stars glow for a very long time. That means they are burning for a very long time. However, they do eventually burn out. Think of a fire in a fireplace or a fire pit, like if you're camping. Now, you went to bed and there was still some fire, but you wake up in the morning and sometimes it's just burnt out. Sometimes it's burning just a little bit, but if you leave it alone, eventually it's going to burn out, right? It's the same thing with stars. But instead of your fire at your campfire burning out after like 12 hours, a star is going to take about 10 billion years. So knowing that about 10 years ago, scientists thought the sun would glow for another 5 billion years, do we have to worry about that burning out anytime in our lifetime? No. Because 10 years ago, they said 5 billion years. So now it's still pretty much 5 billion years. Just a little less. Okay. Now, we're going to read the light years column. Then, we're going to look at the diagram. Pay close attention when I'm talking about the diagram. What do you think that means when I say pay close attention when I'm talking about the diagram? Excuse me, Aaron?
It'll be on the independent practice.
You're probably going to see it again on the independent practice or morning work tomorrow, depending on how much time we have. Okay, I will read next. Don't use this as a chance to zone out. Keep following along, because what if I stop in the middle of a paragraph and call on somebody? That's likely. Light years. When you observe the night sky, one star may seem brighter than another. That happens. Sometimes we look up and we're like, I can barely see that star, but that star's super bright. Does that star give off more energy? Like, is it burning hotter? Is there more burning gas? Maybe not. It may simply be closer to Earth than others. Think of the sun. It's the closest star, so it looks huge, and it's so bright that it gives our whole world light. Now, could we read by the light of the stars? No. Because they're so much further. Well, some stars look brighter, not because they're bigger or give off more energy. Sometimes they're just closer. Not as close as the sun, but close enough that they look brighter than others. The sun is about 150 million kilometers from Earth. It takes about 8 minutes for its light to reach Earth. So that means the light leaves the sun, and after about 8 minutes, we see it here. So this light shining outside right now. Look out the window. Zari, look out your window. That light moves. That light that we see out the window right now left the sun about 8 minutes ago. So when we were talking about the colors of stars, when Lena was reading to us about the colors of stars, that's when that light that we see right now is leaving the sun. So that's how long it takes from light to get from the sun that's the light to us on Earth. It takes about 8 minutes for this light to leave here and get to here. Most stars are much further away. They are so far that scientists measure their distance in light years, not kilometers, like the distance from the Earth to the sun. They measure in light years. 1 light year is the distance light travels in 1 year. Let's add that word. Light year. Make sure that you're making it singular, not plural. Light year. The distance light travels in 1 year. So that means if we are 1 light year from a star, so remember how we talked about how long ago did the light we see out the window leave the sun? Michaela?
8 minutes ago.
8 minutes ago. If a star is 1 light year from us, that means if we're looking up at the star, we see that light left that star a year ago. If it's 1 light year away, and we're looking at that star, that means that light that we see left that star back on April 12th, 2020, right as we were beginning this whole pandemic. But what if a star was 10 light years away? How long ago? The light we see right now, say there's a star up above us and it's 10 light years away. How long ago did that light leave the sun? Lena?
10 years
I mean that star. How long did it?
10 years ago.
10 years ago. That means the light left the star before you were born. Or before Carla was born. And right after Smith was born. Or no, Colin was born. And Smith. What if a star is 36 light years away? How long ago did the light, we're looking up at the star, we're looking at it right now, we see it, but it's 36 light years away. How long ago did the light we are seeing right now leave the star? Kingston? 36 years ago, before I was born. Okay, let's keep going. We can talk about that all day. Read next. Aaron, loud and slow.
When you see a distant star, you are seeing what it looked like millions of years ago. A star you see today may have stopped glowing long ago. However, its light is still making its way to it.
So, the star I mentioned that's 36 light years away, that's a close star. There are stars that are millions of light years away. That means when that light left that star, dinosaurs were alive. Dinosaurs were living on the earth when that light left that star. That star may have burned, that's how big stars can be. That star may have burned out thousands and thousands of years ago. But the light from millions of years ago hasn't even made its way to our Earth yet. That's why space is so wild and so interesting. Because something we are seeing now left that star millions of years ago. That star doesn't even exist anymore. But do you think any of our probes can make it millions of light years away? How long do you think it would take a probe to get to something that's millions of light years away? Zari.
Over the time that, maybe
Like how long? Give me a number. How many years?
infinity.
Not infinity, but close. It feels like it. Ethan? Millions of years. It might take millions of years for a probe to get from Earth to a star that is millions of light years away. And do we think that there are any machines that can last that long? Will there be people around even that long to work it? Maybe not. So that means we can't tell if the stars we're looking at, we can't really tell if they're still shining or if they've burned out. Because if it's millions of light years away, there's no way to tell when or if it has burned out. That's why stars are crazy. Stars are very interesting for that reason. Okay, let's look at this diagram. We gotta move on. We have 25 minutes. So this diagram will probably be your morning work tomorrow morning. This particular diagram. Let's look at it. We see a timeline, or not a timeline, a number line that starts at 0 and ends at 12. We see the word light years below. That means each of these numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, represent 1 light year. So of course we have the sun. It is 0 light years away from us. Because how long does it take light from the sun to reach the earth? Mason? 8 minutes. Not a year, right? So it's way less than 1 light year away. So put your finger on 0 light years. That's where the sun is. The sun is only about 150 million kilometers, which are like only, well, compared to everything else, yeah, only. It's less than a light year away. It's only 8 minutes away in light. Then we go to 1 light year. Have we found any stars yet? 2. Any stars? 3. 4. We're starting to see some. These are the closest stars. There are no stars closer than 4 light years away. What star is the next closest? We have the sun, and then we have what star? What is the name of it? How far away is it? Zadie.
Alpha Centauri.
Alpha Centauri.
Alpha Centauri, 4.2 light years away.
So, the next closest star after the sun is Alpha Centauri. And it's about 4.2 light years away. So how long ago, if we look outside and we see Alpha Centauri, how long ago did that light leave that star?
About 4 years ago.
About 4 years ago. Now, do we see any stars 5 light years? 6 light years? 7 light years? 8 light years? 9 light years? What's the next closest star to the Earth? So we have the sun, and then about 4.2 light years away is Alpha Centauri. Then we have what? Carla?
The secret,
No, not secret.
the sacred,
There's no C in that word, Carla. Who can help her out? Especially Harry Potter fans. Lena?
Cyrus,
Sirius. Sirius A.
Sirius A.
And how far is Sirius A from us?
Sirius A is 1.5
light year away.
Look closely, Carla.
I mean 8.6 light years away.
8.6 light years away. So if we go outside and we see Sirius A, about how long ago did that light leave Sirius A?
8.6 light years ago.
Not 8.6 light years ago, just 8.6 years ago.
8.6 years.
Light years is how long it takes. I mean, light years is how long the distance light travels in a year. It takes 1 year for light to travel 1 light year. So, if we go outside and we see Sirius A, that light left that star about 9 years ago. 8.6 is close to 9. Next, we have what? Cullen.
Ross 154.
Ross 154. How far away is Ross 154?
9.5 light years.
9.5 light years away. So if we go outside and we see Ross 154, about how long ago did that light leave that star?
9.5 years.
So about 10 years ago. Around the time you were born, if you see Ross A, that's when that light left that star. What do we have next? Zari.
Veronica.
Not Veronica. That's C. I'm pretty sure it's a soft C. I'm pretty sure it's a soft C.
Procyon.
Close, I think. Procyon. But finish out the name.
Procyon A.
Procyon A. How far away is Procyon A, Zari?
11.4 light years.
11.4 light years away. So, how long ago, if we go outside and we see Procyon A, how long ago did that light leave that star?
About 11 years ago.
About 11 years ago. So I don't think any of you were born yet. None of you were born yet. If you see Procyon A outside, none of you were born yet when that light left that star. Okay, let's look at the question below. In this diagram, Earth is right next to the sun at 0. How long does it take for light from Alpha Centauri to reach Earth? How long? I've actually already answered these questions. But I want to ask you in this format to see if you can figure it out. Mason? not 4.2 light years. Remember, how far is it would be 4.2 light years, but how long ago did it leave would be 4.2 years ago. What about from Procyon A to Earth? How long ago did the light leave Procyon A? Helen?
11.4 years.
11.4 years. So keep that in mind. So when you see your morning work tomorrow, you know what to do. Okay. Mason, please read next.
Galaxies. Throughout the universe, stars are found in large groups called galaxies. Our sun is near the edge of the galaxy with billions of other stars. You know this galaxy as the Milky Way.
So, we know the Milky Way galaxy. We're part of the Milky Way galaxy. It's named after what? No? What do you think it's named after? Kingston?
I don't know. Really answer.
Not milk. What do we sometimes call the asteroid belt? When we see the light from the sun shining on it, it looks like a band of a bunch of asteroids or a bunch of stars, but it's really just the light. Well, what color are they? Think of how many there are. What color is the light on the moon? Mason?
Gray.
Grayish white. What color is milk?
Wisdom.
White. So if we see that band of asteroids, they're kind of white. So that's where we get the Milky Way from. Keep going, Mason.
Our galaxy's nearest neighbor is the
Use the pronunciation key. What's the first syllable?
and
Second syllable? Drom. Next syllable?
is
Last syllable.
the
So Andromeda. If we put it all together, no spaces, it sounds like Andromeda. Andromeda. Who can help him out? Michaela?
Andromeda.
Say it loud so he can hear you.
Andromeda.
Did you hear her? Or does she need to say it even louder and yell it?
Andromeda.
Andromeda.
Our galaxy's nearest neighbor is the Andromeda galaxy. It is shaped like a
It's a long I.
spiral.
Spiral. This picture on 394, that's the Andromeda galaxy. You can see it's shaped like a spiral. It kind of looks like it does this. Keep going.
The universe may have many more galaxies, each with billions of stars. These are yet to be discovered.
So look at the Andromeda galaxy. Who wants to count those stars? Anybody want to count those stars? No, there's like thousands there. Galaxies have a massive amount of stars. There are galaxies that we don't even know about that may have billions upon billions of stars. So have we seen and named every single star in the sky? Do you think we ever will? Probably not. And if we do, it'll probably be billions of years from now. Okay. Now, in your own words, how far away are stars? Other than the sun, in your own words, how far away are stars? Aaron?
They're far enough away that they're tiny, but they're close enough that we can still see them.
Oh, that is really, really good, Aaron. Can you come up here and say that exact same thing, but loud so everybody can hear? You can wear your face shield. We can hear you better with your face shield on. And as long as you have one or the other, you're okay. Come up here and tell us that again. I'm glad that's on video. That's like the best answer I've ever heard to this question.
They're far enough that they're not as big as the sun, but they're close enough that we can still see them.
Very good. Like, that's probably a better answer than what I would have given if somebody had asked me. They're far away. They're really, really, really far away, so they look tiny. And they are light years away, which we know a light year is really, really far distance. But they're close enough that we can still see them. Because again, like we just said, we can't see every single star in the sky. Otherwise, we would have discovered them all. And have we discovered everything space has? No, not even close. Or, well, maybe we're close. We just don't know, but probably not. Very good. Listen to this sentence. Temperature determines a star's color. Temperature determines a star's color. Is that a fact? That means it can be proven. Or is it an opinion? Is it something that I feel that can't be proven? Lena.
It's a fact.
It's a fact. We can prove it. In fact, it says colors and temperatures. The colors are due to temperature. That's a fact. It's proven. Opinion means I just feel that way, and it could be disproven, but that's true. If a star's hot, it's what color? Star's really, really hot, it's what color? Cullen? Blue or white. If it's cooler, what color is it? Carla?
Red or orange?
Red or orange. And then we've got the sun that's kind of in the middle, so it is,
Yellow.
thank you. Class?
Yellow.
Yellow. Okay, turn the page. If we can get through this page, then you can do all the morning work tomorrow. Otherwise, that'll be something you have to add to your review tomorrow afternoon. Smith, go ahead and read.
What are constellations? Billions of stars. How could you make sense of all of them? One way is to group them into constellations. A constellation is a group of stars that make a pattern or picture in the sky.
So, what's our next word?
Constellation.
Constellation. And what is a constellation, Smith?
A group of stars that make a pattern or picture in the sky.
A group of stars that make a pattern or a picture in the sky. So, constellations are a group of stars that make a pattern or picture in the sky. So when we talk about the Big Dipper, the Little Dipper, or Orion, it looks like a picture. The Big Dipper looks like this, but I think I'm doing it backwards. And those are all the stars. And if you connect it, looks kind of like a ladle. The Little Dipper looks the same, just smaller. Those are constellations. They make patterns or pictures. They're groups of stars, so each one of these is a star. And they make patterns or pictures in the sky. Smith, keep going.
Our constellations make sense only to an observer on Earth.
What that means is, if I'm an astronaut and I'm up in space or I've landed on the moon, if I look for the Big Dipper, I'm not going to be able to find it. If I were to one day be able to live on Mars, I wouldn't be able to see the Big Dipper anymore. Why is that? Keep going.
Stars that seem close together may actually be very far apart.
That's like Aaron's answer to that question. They look really far away, but close enough that we can see them, so it looks like they're really close. But the closer you get to it, the farther apart they would move. Okay? Hold on, hold that thought till the end. Keep going, Smith.
If you move to a different part of the universe, those patterns change.
Very good. So imagine, have you ever seen those optical illusions where if you kind of look at it from below, it looks like one picture, but then if you look at it from above, it looks like a different picture? Have you ever seen those? That's like what the stars are. If you look at it from one place, it's going to look one way. But if you look at it from a different place, it's going to look entirely different. That's what they mean here. If you're on Earth, the stars will look one way. But if you go to the moon, or to Mars, or to Mercury, or to Jupiter, or out of our galaxy, it's going to look completely different. Keep going.
Constellations also depend on the position of the observer on Earth.
So, that means not only will the pattern change if you go to another planet, but if you go to another part of Earth, you're going to see something different. So people in like South America may not be able to see the Big Dipper or the Little Dipper like we can, but they get to see other stuff. Keep going.
The night sky looks different in the northern hemisphere than it does in the southern hemisphere. Still, a few constellations appear in both.
So remember, here's the Earth. The northern hemisphere is separated by the equator from the southern hemisphere. So if you're above the equator, you're in the northern hemisphere. You see one set of constellations. If you're in the southern hemisphere, you're below the equator. You see space from a different angle, so you may see some different constellations. However, there are a few constellations that appear in both. Let's look at the diagram at the top of page 396. Pay close attention. We see this circle with constellations. This is what we can see from the northern hemisphere. Find the circle with the constellations we see in the northern hemisphere. Now, look at the other circle. If you're down here in South America, you'll be more likely to see these constellations. Now, look at both of them. Can anybody find a constellation that appears in both the northern and the southern hemisphere? Michaela.
Oregon.
Not Oregon. What is it? Where is it? Do you see it in both? Orion. Orion. So find Orion. It's right almost all the way off on the right part of the northern hemisphere and almost all the way off on the left part of the southern hemisphere. So put your finger on each one. If you can't find it, raise your hand. It's all the way almost off of the circle on the right of the northern hemisphere and all the way almost off the circle on the left of the southern hemisphere. Okay, I was making sure that you weren't like pointing to something. Okay. Oh, do you see another one that appears on both?
And I just
Okay, I get it. I get where you're doing that now. Okay, if you can't find it, please raise your hand and I will come help you. You got it?
To the left, on the northern hemisphere, all the way to the right, on the southern. Do you see it? So find Orion. Now find Orion. There you go. So we're looking all the way over to the left here for Orion, and all the way to the right over here for Orion. Find Orion. There you go.
Anybody else? Does anybody else need help?
All the way to the left for Orion in the northern hemisphere. And all the way to the right for Orion. There you go.
So, notice how you can see Orion. Zari, did you find them?
I have two things.
Well, hold on because we need to talk about this really quick, okay? So notice how you can see Orion in both, but it's almost to the edge of each one. Well, what would happen if you moved those circles and you moved the southern hemisphere up a little and then made them meet? They would overlap, right? Because that's how we see the sky. The northern hemisphere sees all the stars we can see from here to here. And then the southern hemisphere sees all the stars you can see from here to here. So they overlap a little with the constellations that are kind of right above the equator. So where do you think Orion is? Right above what? Smith?
The equator.
The equator. Now there's a couple others. Cullen, I think you were the first one that I noticed. Notice.
I don't know how to say it.
Try it. Chunk it. First three letters, how would you say it?
Like cute.
You might be thinking of a different one.
I was thinking of that.
Okay. Pisces. Pisces. Smith is mad because she is a Pisces. Well, no, you're not a Pisces, are you?
No,
Oh, you just found that too. Okay, never mind. You're not a Pisces. 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 It's at the top of both. So they're either in the same place or they're in opposite places. Because now look all the way to the left on the southern hemisphere. Look all the way to the left. Find Serpens. Serpens. Find all the way to the left on the southern hemisphere. Find Serpens and then put your thumb up. Southern hemisphere. On the southern hemisphere, all the way to the left. Find Serpens. You're looking at the right. Sadie. Nope, I'm wrong. All the way to the right. And find serpens on the southern hemisphere. Told you I don't know my right and my left. Look all the way to the right on the southern hemisphere. Other side. Find serpens. S-E-R-P-E-N-S. Now look all the way to the left on the northern hemisphere and find serpens. S-E-R-P-E-N-S. So here we have the constellation on opposite sides. Orion is on opposite sides of each hemisphere. Serpens is on opposite sides. But Pisces is both at the top. That's because some of them we can see, and either they're going to be in the top, the same place, or completely opposite. So if I'm in the southern hemisphere, will I be able to see Ursa Major? Ursa Major is the Big Dipper. Oh, yeah, there might be more than one. Can you find Ursa Major in the southern hemisphere? Make sure it's Ursa Major, not Canis Major. So if I'm in South America, can I see the Big Dipper, Ursa Major? Ursa, U-R-S-A, and then the word major. Aaron? No, I can't. So that means if you move to South America, well, while you're at home, you won't really get to see the Big Dipper. You can come back and visit and see it, but you won't really be able to see it at home. What about if I am in the United States, which is in what hemisphere? Class? Northern hemisphere. Can I see Crux? C-R-U-X. Crux. C-R-U-X. If I'm in America, in the northern hemisphere, can I see Crux from where I am? Zari?
No.
No, I can't. So remember, depending on where you are on Earth, you may not be able to see the same constellations as if you were in another place. Because if I'm in North America in the northern hemisphere, I can see Ursa Major, but I can't see it in the southern hemisphere. Well, if I'm in the southern hemisphere, I can see Crux, but if I'm in the northern hemisphere, I can't. So remember, constellations depend on where you are, either on Earth or in the solar system. They're going to look different. Okay, so keep that in mind for when we do the independent practice tomorrow. Yes, quickly, is this what? Okay. Okay, so we'll finish patterns of stars, marking time and seasons, and the what is the sunlight heading tomorrow. Okay, you will have extra credit vocab homework tonight. I will pass it out right now. Zari, the independent practice that I sent to you earlier, that will be morning work tomorrow. So please do not send it to me at 8:15 because it should not be completed by 8:15 tomorrow morning.